Let's take a look at what are we going to cover in this video. Definition. So what is ZKP? Zero-knowledge proof, or also called as ZKP, is a cryptographic method that includes interaction between two parties where one wants to prove certain information or verify it without leaking it while the other wants to verify the fact of information. Let's look into the history of ZKP. The notion of zero knowledge was first proposed by MIT researchers Shafi Goldwasser, Silvio Maccali, and Charles Rakoff in the 1980s. The origin of this system of thoughts occurred when the researchers were working on a problem to the interactive proof system, a theoretical proof concept where the first party, prover, exchanges some messages and calculated results with the second party, verifier, to convince the verifier about some information without actually revealing that information. Working. Let us understand how does ZKP works. The prover has some secret information. He wants the verifier to know that he has that information. The prover performs certain calculations and sends its results to the verifier, such that the verifier cannot brute force or guess that data. Then prover performs certain other calculations using that same data and sends it to the verifier. The verifier cannot guess the data, but he can verify that the data used for both the calculation is the same and follows certain case-specific properties. So here is how zero-knowledge proof works. Now let's have a look at what are the benefits of ZKP. This method ensures the security of data. We can say that the actual data was never transferred. So, even if a cryptographic attack gets successful, then also the attacker will only know that the prover has certain information but cannot access the information. Secondly, password security is greatly improved compared to currently used techniques. Next is that prevention of data breaches and provides anonymity. Adding to this, some secrecy problems related to office work and culture can be solved by it, as it doesn't require revealing the data. A secured and breach-proof data transmission channel can be created. Blockchain and cryptocurrencies are believed by many to be anonymous systems and hide their identity, but it is false. They just keep it confidential. Government agencies can track, and they have done it in past. Crypto based on ZKP can solve this problem. No history is created. Now it's time for us to look into the limitations of ZKP. Firstly, speed is slow. Proving process takes time, and in the digital world, it is to be done by the computers and digital gates which have a certain time of operation. A hardware implementation sometimes requires thousands of gates to verify and generate very complex proofs. It can be used to craft a hacking attack by evading the supervision system due to privacy granted by ZKP. Tampering with messages and proofs is possible. Now it's time for us to look at the real-world applications of ZKP. Some of the real-world applications are: password login into any website. Solution. The user, instead of sharing the password, can just send some computations and results to assure the server that the user knows the password. These computations can be done by application or API installed at the local machine of the user. ZKP adds a high-end security level to every block containing sensitive banking information like your credit card details and history, such that banks need to manipulate only required blocks when a user requests information. Other blocks remain untouched and thus protected. Adding over to these are: certain blockchains and crypto use public databases and the cloud to store wallet information and other important ledgers. Thus, the information in blockchain is only confidential but not anonymous. Solution. Zero-knowledge proof protocols are important in the field of storage, as they safeguard the entire storage unit and also the channels of transfer. 3-color graph problem. Solution. The service provider of graph coloring, which may be a powerful computer or a large company, can show 2 vertices at a time to the customer and then shuffle it, maintaining the 3-color scheme. This repeated process will generate the confidence of the customer, and then he will pay. Also, the service provider will not have to give off a solution without payment. Let's have a look at the real-world deployed products based on this. First is ZK-SNARKs. ZK-SNARKs stands for Zero Knowledge Succinct Non-Interactive Argument of Knowledge. Secondly, Zcash, crypto based on ZKP. Third is ZEXE, purpose-controlled privacy solution. Fourth is Zcoin, standard for making new cryptocurrencies. That's it from our side on zero knowledge proof. Thank you all for your patient hearing.